Okay, guys, we're back, and I hope this hasn't been too awful yet. I accept the fact that you really probably don't like the things we've done for the last couple of days. That row echelon reduction is not for everyone. Some of you might have clicked, and that's great. The bulk of people just, even if they get it, they don't like it, and sometimes you just never get it. So we're stepping back to something a little easier now. We're still working with these matrices, but we're not working with augmented matrices. We're treating the matrices as mathematical objects that can be manipulated. And by manipulated, I'm talking about the fundamental basic operations. So today we're going to look at adding and subtracting matrices. We're going to look at something called scalar multiplication, and then there's a second type of multiplication called matrix multiplication. The first two are very easy. The third one is not difficult, but it's a little tedious. And in order to learn the third one, we do have to go over something called dimension, which I mentioned in passing in a previous video, but I didn't make a big point of it. So we need to talk about dimension. So a matrix has rows and columns. If I could spell it right. And the dimension of a matrix is written as rows by columns. Columns, that's an N, not a B. Jeez, oh Pete, is that coulombs or column? Okay, rows by columns. So, as an example, here's, okay, 1, 2, 3, 4, 5, 7. Okay, those of you with a little OCD, deal with that. Anyway, this matrix has 2 rows and 3 columns. Just like in architecture, the columns go up and down, like the columns that support a building. So there are 2 rows by 3 columns. That's a 2 by 3 matrix. If you don't like the fact that I used a 7 or I used a 7 instead of a 6, at least now it's crossed out, so you got that going for you. All right, let's look at this example. Yes, that is a matrix. That is a 1 by 1 matrix. This matrix, 5, 6, 7, 8, and this matrix, 5, 6, 7, 8, are not the same. They do not have the same dimension. This is a 4 by 1 matrix, 4 rows, 1 column, and this is a 1 by 4 matrix, 1 row, 4 columns. So you have to have sort of a fundamental understanding of what that is. If it helps, it's also, you can look at it as horizontal by vertical. Although rows by columns is the language that mathematicians would use, but horizontal by vertical, if that helps. All right, let's do this. Very, very simple. Oh, I guess I should mention, in order to add or subtract matrices, they have to have the same dimensions. So this is a 4 by 1, this is a 4 by 1. That means they can be added together. The answer is going to be a 4 by 1, and quite simply, you do 3 minus 1 here, 0 minus negative 4, and when you minus a minus, it turns to plus, so that's positive 4 there. Then you have negative 1 minus 4, which is negative 5. And then negative 3 minus 3. Negative 3 minus 3, of course, is negative 6. I hope you weren't thinking 0. Not 3 minus 3, negative 3 minus 3, negative 6. But that's your answer, and that's all there is to that. Let me check. Just got done teaching an algebra lesson, and boy, I sure screwed up one problem, and I left it in the video, so I felt like I'd be a liar if I edited it out. So there we go. All right, number 4. Negative 1 minus negative 6. Negative 1 minus minus turns to plus plus. That's going to be a 5. 3 minus minus 5. That's going to turn to plus. That's going to be 8. Negative 6 minus negative 5. That's going to turn to plus, and that's going to be a negative 1. And then 2 minus negative 3. Again, those two minuses will turn to plus, and that's a 5. I guess I could have done a better job. And there we go. 5, 8, negative 1, 5. Well, look at that. All my examples are subtraction. Well, that was kind of dumb. Let me go down and check Number 4, 5, 8, negative 1, 5, 5, 8, negative 1, 5. Yep. Okay, if this was addition, I would just be adding every pair of numbers together. Oh, well, boy. I would add this with this, that with that, that with that. All my examples happen to be subtraction, but addition and subtraction are the same thing. So, negative 4 minus minus 2. Minus minus turns to plus. Negative 4 plus 2 is negative 2. That was a mess. Negative 5 minus 4, that's negative 9. And then negative 3 minus negative 4, that turns to plus. Negative 3 plus 4 is 1. So that's it. That's how you add or subtract matrices. You just pair up the numbers and add them or subtract them. So the homework you're going to do, this one is adding, this one is adding, this one is subtracting. Now, these are fairly simple matrices. You could have something really crazy like 1, 2, 3, 4, 5. Okay, that's a 7. 4, 5, 8, negative 2, 0, 1. Plus 0, negative 2, negative 3, 5, 7, 2, 8, 6, 12. And this could be done. You just have to add each and every pair of numbers together. Of course, these were both 3 by 3 matrices, so your answer would be a 3 by 3. You just pair them all up and add them all up. All right, let me get that off of there. You don't need that in your way. But that's the point. Adding and subtracting matrices, really easy. Okay, number 7 through 10. This is what I was calling before scalar multiplication. Just, abbreviate that. Scalar multiplication is quite simply just a ginormous distributive property. You're going to multiply negative 3 into this matrix and get 9, negative 18, positive 12, positive 6. And that's it. That's the answer. I didn't check the last one, so let's check 6 and 8. 6 was negative 2, negative 9, 1. 8 is 9, negative 18, 12, 6. 9, negative 18, 12, 6. Number 10, distribute or scalar multiplication. That's a number times an entire matrix. You just distribute the number into the whole matrix. So the answer is going to be negative 10, 15, negative 25, positive 10. So when you go to do 7 and 9, it's just a distributive property. This negative 3 gets multiplied by every element in that matrix. This negative 4 gets distributed or multiplied by every element in that matrix. And that's all there is to it. Even if I did a bad job here, I may have, I don't know, I'm kind of tired. Even if I did a bad job, when it comes to adding and subtracting matrices and scalar multiplications, it should be still fairly easy to learn and pick up on. The only mistakes I foresee anyone making is possibly having issues with signs. Like every so often you slip up that, the double negative equals a positive, so that could throw things off. Or sometimes you try to do some negative numbers in your head and it doesn't quite work out. So like, negative 1 minus 4, yeah, the answer is negative 5, but maybe someone would have an off day and write down 3 or negative 3 or something like that. So that's something to look out for, but generally the principle is very simple. Either add or subtract the numbers with their partner number, like sort of pair them up, or down here just distribute the number into the entire matrix. So that's the easy stuff. Now, multiplying matrices together, a matrix times another matrix, it's a whole other scenario. Let me get to this even one. Very similar. These are two very similar problems, so it should be good. First thing you want to do is write down the dimensions. So this is a 3 by 2 matrix, and this is a 2 by 2 matrix. You can only multiply matrices if these inner dimensions match each other. If those two are the same, you can do it. If they're not the same, you actually write undefined next to the problem, and that's all you do. So this is doable if those two numbers match. The answer is going to be, let me change colors here, a 3 by 2. The outer dimensions tell you how big your answer matrix is going to be. So my matrix is going to have 3 rows and 2 columns. Okay, the first thing you do is you multiply this row by this column. Now, what does that mean? It's sort of turning this sideways. The 6 gets multiplied by the -2. The 5 gets multiplied by the -3. 6 gets multiplied by -2. 5 gets multiplied by -3. And then those are added together. And that goes in the first spot. Then you do this row again times that column. 6 times 6, 5 times 0, and they get added together. And that's the second number. Now, when we've done the first row by both columns, you're done with the first row. Move on to the second row. This row times this column. -3 times -2 plus -2 times -3. Then do the second row times the second column. -3 times 6, and -2 times 0. And you add those together. We've done the second row by both columns. We're done with it. Move on to the third row. This row times this column. -2 times -2 plus -4 times -3. Then do that final row by the final column. -2 times 6 plus -4 times 0. Then you need to work this whole mess out. So up here we're going to have -12 plus -15, 36 plus 0, 6 plus 6, -18 plus 0. What am I doing here? Have you gotten lost? I simplified this and wrote it here. I simplified this and wrote it here. But I haven't simplified it all the way. I'm just kind of doing steps. This one, and I wrote it here. Simplified this one and wrote it here. I'm about to do this one, and I'm going to write it there. So that's going to be -2 times -2 is 4, plus -4 times -3 is 12. And then I'm going to do this row and put it here. -2 times 6 is -12, plus -4 times 0 is 0. Then I can finalize it. So what do we have? -12 minus 15 is -27. 36 plus 0 is 36. 6 plus 6 is 12. -18 plus 0 is -18. 4 plus 12 is 16. -12 plus 0 is -12. And this is the solution matrix. Let's see, can I keep all those numbers in my short-term memory so I scroll down and check it? Probably not, but I'll try. -27, 36. Right there, -27, 36, 12, 18, 16, 12. Yep, that's right. So that's how this is done. Go back, rewatch it, pause it if you need to, or we'll just do a few more and hopefully it'll all make sense once you get used to it. This first matrix is a 2 by 3, 2 rows, 3 columns. The second matrix is a 3 by 2, 3 rows by 2 columns. So are they compatible? Can we multiply them? Yes, those numbers match. Furthermore, our answer matrix will end up being a 2 by 2. So let's do this. I need to multiply this row by this column. How does that happen? I do 6 times -5 plus 6 times 3 plus 3 times -1. Then I realize that I'm going to be running out of room, so I'm going to move this down here. So we did the first row by the first column. Now we need to do the first row by the second column. 6 times 1 plus 6 times 3 plus 3 times negative 4. The first row has done both columns, so we're done with the first row. Now we do the second row. This row times this column. 4 times negative 5 plus 6 times 3 plus 5 times negative 1. Then we have to do second row, second column. 4 times 1 plus 6 times 3 plus 5 times negative 4. Now we need to work this out. You could grab a calculator here if you want to make things a little less tedious. I'll still do mental math, so this is going to give me negative 30 plus 18 plus negative 3. Over here I'm going to have 6 plus 18 plus negative 12, negative 20 plus 18 plus negative 5, 4 plus 18 plus negative 20. And then I have some adding to do. Let's see, negative 30 plus 18 is going to be negative 12, minus 3 is negative 15. 6 plus 18 is 24. 24 and negative 12 is 12. Negative 20 plus 18 is negative 2. Negative 2 and negative 5 is negative 7. Oh, there's my dog. Well, Champion says hi. 4 plus 18 is 20. 22. 22 minus 20 is 2. Yeah, someone walked by outside and it spooked him. Champ, buddy, you're okay. All right, let me check this with number 14 down below. Negative 15, 12, negative 7, 2, negative 15, 12, there it is. Okay, we'll do this last one. It might be getting kind of tedious right now. Oh, by the way, we mentioned that on this one the answer would be a 2 by 2, and it was a 2 by 2. Just want to point that out. All right, this last one, if it's getting tedious, I'm sorry, but the presence of these zeros will make things go a lot better. So, this is a 2 by 2. This is a 2 by 3. Since those numbers match, we can do this, and our answer is going to be a 2 by 3. So, this row times this column. 3 times 6 plus 0 times 4. This row times this column. 3 times 6 plus 0 times 1. This row times this column. 3 times negative 5 plus 0 times negative 3. We did the first row with every column. We're done with it. Let's go on to the second row. I'll change colors just for whatever. This row times this column. 6 times 6 plus 0 times 4. 6, 0, 4. Then we do times this column. 6 times 6 plus 0 times 1. Then we do this row times this column. 6 times negative 5 plus 0 times negative 3. Simplify all this. Well, this is going to be easy. 3 times 6 is 18. 0 is just 0, so that's going to be 18. That's going to be a 0. 3 times 6 is also 18. That's going to be 0. 3 times negative 5 is negative 15. That's going to go away. 0 times anything is 0, so 6 times 6 is 36. That goes away. We have another 36. That is going to go away. 6 times negative 5 is negative 30. And I wrote that kind of funky looking. I don't know, I had it kind of spaced out for whatever reason. And there is the answer for number 16. Let's see. Oh, whew. I was looking at 15. I'm like, oh no, I got it all wrong. Number 16 right there. We're looking good. Okay. So, page 1 should be pretty easy. Add when you add, subtract when you subtract, distribute when you multiply. Matrix multiplication is a whole other story. You have to do each row times each column in every possible combination and work that out and see if you can do it. Now, here's the moral conundrum. Do I make you really struggle with this? Or do I give you a little tip? Well, I suppose at this point I should give you a little tip. I'm not going to be specific. But if you maybe do a Google search of matrix, matrix calculator, you might find something online where you can just type in this matrix, and tell the calculator to multiply them, and it'll spit out that answer. And then type in these two matrices and it spits out that answer. And then type in those two matrices and it spits out that answer. In fact, there might be dozens of matrix calculators online. Maybe you might want to explore that as an option so you don't have to put yourself through the tedium of all this. And those people who just try to figure out the homework without watching the video, they might miss that whole point. I don't know. We'll see. And just maybe Desmos has a matrix calculator. Not the Desmos that we already use, but they have like a second calculator that does matrices. Just maybe, hint, hint, wink, wink. Okay, so I'm going to stop there. Contact me through comments or email if you have questions. Good luck on this. Do your best. And yeah, look for that calculator. Talk to you later.